Would be fine if it were downhill all the way to school and then downhill all the way back home. Too bad. The world just isn't made that way. All your life long, you'll be digging in and making your muscles work for you. But you and Joan and Jimmy are lucky. You're living in a very special time in the world's history, a time when other kinds of power help you to get to school or do the other things that need to be done. Long years ago, all the work of the world was done with this power alone, with human muscles. Indians used the power of their muscles to grind corn. Every job was done by muscle power, whether skinning a buffalo or boring a hole in a seashell. Years went by and people learned to use animal muscle to work for them. But the work was slow and heavy. They looked for other kinds of power to help them. Then people found how to use the power of the wind. It's much easier to let the wind push than to carry a heavy load with muscles. The power of the wind will work for us on land, too. The only work that this windmill is doing is to wear a little skin off Jimmy's finger. But a windmill will run a machine that pumps water or does other useful work. Another kind of power that people discovered long, long ago is water power. Water flowing in rivers can carry boats and heavy logs and rafts. Water power will turn wheels, too. Little wheels for fun or big wheels for work. When men first settled in our land, they built water wheels in the streams. On the banks, they built their mills and factories. The power of the water turned the machines. Today, we build our factories far from a river, and yet the power of a river may be the power that runs the factory. The power comes along the pathway of electric wires. Let's see how we can use the power of flowing water to do work for us in a factory many miles away. First, we make the water turn a water wheel. This wheel turns a machine called an electric generator. When the electric generator turns, electricity flows from it, flows through wires to the factory far away. Here inside our factory is a real electric motor, tiny but real. If we attach wires from a generator, electricity makes the motor turn. And when a motor turns, it will run machines that work for us. Do you know how electricity can make something turn? Let's find out by building a real electric motor of our own. As Joan doesn't happen to have a flowing brook and a water wheel and a generator in her room, she can use electricity from a battery. Joan has wrapped a wire around a nail. When she connects the two ends of the wire to the battery, electricity flows through the wire. Something strange happens. Watch. A magnet. The wire and nail together are called an electromagnet. You can make an electric motor with the electromagnet, like this. Here is a cardboard box top, balanced, so it will turn easily. The electromagnet pulls the nearest paper clip. When Joan stops the electricity as one clip goes by and then starts it again, it will pull the next clip. Pull, stop, pull, stop, pull, stop, pull, stop. Simple, isn't it? And yet a real electric motor works in almost the same way. In your home, the power from an electric motor pushes air on a hot day and washes your blue jeans and tells you that you're going to be late for school if you don't hurry. But don't forget that the electric power that turns so many of our machines comes from some other power. Here is another useful kind of power. Before you were born, the power of steam in old locomotives like this pulled the heavy loads across our country. Whether the engine is a locomotive or a toy steam engine, the main parts are the same. There's a boiler that holds water. And there's a fire that changes the water into steam. When the water boils into steam, the pressure of the steam makes a wheel turn. In this kind of engine, the wheel is turned by a piston that goes in and out. The power of steam will turn a wheel in another way. You can make a steam turbine by cutting a piece of aluminum kitchen foil like this. A pin stuck in a pencil eraser will hold it. Steam turbines are used to turn the propellers in huge ships. Imagine how much power it must take to turn this propeller. And in many places, the electricity that turns the motors in our factories comes from the power of steam. You can see how steam power will turn a generator just as water power turns a generator. When the generator turns, electricity flows from it. It flows through wires to turn the motors in our factories and light our cities. Another useful kind of power is the power that comes when something burns. Even the flame of a match has a great deal of push in it. Here's an experiment that shows the power of fire. First, we'll put 2 matches in a small bottle. If you do this experiment, wet the stopper and put it in the bottle loosely. Now we'll light the matches with a magnifying glass. Watch. When the matches light, hot gases push out the stopper. It's not hard to see how the power of hot gases can be used to turn wheels. However, instead of matches, you're a good deal more likely to find engines that burn gasoline. It's the power from burning gasoline that makes an automobile go. Hot gases from burning oil make the wheels of a diesel truck go round. Hot gases push jet planes and rockets through the air. The gases shoot out through a tube in this model plane just as in a real jet plane. In years to come, when the sun goes down, the electricity that lights our cities may come from another kind of power, the power of the atom. You and I can't experiment with atomic energy, But you can find out about other kinds of power. You can move cargoes with the power of the wind. You can do work with the power of falling water. You can use electric current to turn a wheel. You can turn another wheel with the power of steam. You can even make a cork popping machine with the power of burning gases. You and Joan and Jimmy will always go on using muscle power. But you are the fortunate ones. You're living in a time when you have other power to do most of the heavy work that muscles used to do.